So in this segment, we are going to see typical DBMS functionality. So when we have a database management system, so every database management system provides us some functionality. So a database management system define a particular database in terms of its data type, structure, and constraint. So database management system should have a way so that we can load the initial database content. Okay, and each database will give us a some operation so that we can manipulate the database. So the basic operation they are going to provide: retrieval. Retrieval means we want to query or generate we want to query or access the data. All right, we may have some question. For example, I want to see the list of courses which is going to be offered in a particular semester. All right, then modification means inserting a new data, deleting a new data, or update the contents of the data. Or we may want to access or change the database through the web application. Also, the DBMS is going to give us functionality to process or share by a set of concurrent users and application program. All right, so as we said that a database could be used by concurrently used by multiple users, but still we want to keep the data valid and consistent. Other features will be provided by the DBMS, for example, like protection and security. Okay, so a database management system should provide the means so that no unauthorized user should not be able to access them. Only the authorized user should be able to access them. All right, then the active processing to take internal action of data. And the database management system is going to give us also a way to present an visualization of the data. All right, we want to see that records of data um, in a meaningful way so that we understand what this data is about. The DBMS will give us a way to maintain the database and associated programs over the lifetime of the database application. So this system, it's also known as like database software system lifecycle maintenance. So we're going to see a example of a database, and here we're going to see example of a database which is a university application. So we will see a part of university environment. So when we talk about university environment, some entity or object or component in this mini world, we can think about this university world has student, course, section, department, and instructors. So so in a university different courses are offered. Also there are multiple sections. So students enroll sections. Each course have some prerequisite courses. So these are the example of the relationship. So in a world we can think of there are some objects or components. All right, and each of the components or objects are interacting with each other with some relationship. So we are going to see an example how a database looks like. All right, so in this university database we are going to store a list of students. Okay, so a list of students, each student, or we can think about a student like as an object or also entity. So each student or entity has also some attributes by which we are going to define that entity. For example, each student has a name, number, class, major. Okay, and you can see that in each column we are storing the attribute, and each of the row, they are the record of a particular entity. So Smith is a student with 17 student number in class 1 CS major. Brown is another student. Then we have a list of course. Each course has a course name, course number, credit hours, department. We are going to list of section. Each section has section identifier, course number, semester, year, and instructor. All right, and here you can see that actually we are storing the list of section, and also it actually keeps track of one relationship, which instructor is offering or teaching which section. Okay, so one course can have multiple section. It depends on which semester you are teaching. For example, like CS 1310. Okay, in fall 07 you will offer this in fall 07 this course will be offered with a one section identifier, and in fall 08 this course will be offered with another section identifier. So we want to keep track of all the sections being offered in all semester in every year. Okay, and in the same semester, in the same year, there could be also the same course can have multiple sections. All right, and it also defines which instructor is teaching which section. Okay, so this, using the table, using the same view, we are actually defining, you can see that this is defining a relationship between instructor and the section. Then this is keeping tracking of grade. Okay, so each student is enrolling a course, and each course will have an associated grade. So in this record you can see that we are storing only the grade, student number, section identifier, and grade. So using the student number 17, we can see that 17 is student Smith, and section identifier 112 is this math 2410. So that means Smith took this course math 2410 and his grade is B. So that's also defines a relationship, which between student, course. Okay, relationship between student and course. All right, and their grade. So that's another information of course versus course, because each course has a prerequisite. So here also, instead of using the detail of course information, they're using the course number and the prerequisite number. So from here you can see that 3380 database has a prerequisite which is 3320. 3320 means data structure. Database has prerequisite data structure. Okay, so you can see actually how a database, a sample database. So these are the list of student, these are the list of course, and these tables are actually using some information of relationship. So these are the information of student and course. Okay, these are the information of student course versus course, the list of prerequisite courses.